So then this means omega is the nth root of z, or simply z raised to power 1 over n. So now from the theorem, instead of raising z to n, we raise the reciprocal or the inverse of n. So that now from this, we have that z raised to n, 1 over n, is r
Sure.
1 over n.
Sure.
Yes.
On the first line, when you wrote z is equals to re, what's written up there? Your handwriting can't be seen well.
I theta. This is
Is equals to
exponential.
is equals to
Yes,
is equals to r what?
is equal to r cosine theta plus I r sine theta. I've just applied Euler's formula. Remember Euler's formula? Exponential of I theta is cosine of theta plus I sine of theta.
Anyone standing at a urinal?
Too bad about the sales.
What's the problem? Hello?
Nothing, sir. Go on.
The what?
Nothing, sir. Go on.
No, someone was talking. Shall we proceed?
Yes.
Cool. So this should be exponent of I. So I gave you the formula, exponent of I theta plus 2 k pi divided by n, where k runs all the way to n minus 1. And I explained why we only take k from 0 up to n minus 1. I explained this. So the fundamental theorem of algebra tells you that any equation, any polynomial of degree n will always have at most n solutions. So we don't expect this complex number to have more than n roots. They have to be n. So when you count from 0 up to n minus 1, you will get n roots, n distinct roots. The reason we are doing this is roots are simply
I see it too.
coordinates of vertices of some circle, the radius r to the 1 over n. You realize that if you go past n, you'll simply be repeating yourself. For example, if you take n, you'll get the root that corresponds to 0. If you take n plus 1, you'll get the root that corresponds to 1. And I try to explain this by using a unit circle, that if there's an angle here, theta, then if I'm to move around this circle once, one time, 2 pi, then using theta is the same as using theta plus 2 pi, because 2 pi is simply one term, positive or negative, doesn't really matter. So any multiple of 2 pi, if you take an argument, add or subtract any multiple of 2 pi or 360 degrees, you get back to the same angle. So for that reason, the angle 20 degrees, what you achieve by using 20 degrees is the same as what you achieve by using 380 degrees. We have just taken 360 plus 20 to get 380. So if I was to plot 380 degrees, I'll simply plot 20 degrees and then one revolution up to where there is 20. So I've covered 20 plus 360 gives me 380. So that is why we restrict the values of k to be from 0 up to n minus 1. Let me give you an example and explain. Maybe to be more clear, I can give an example. So suppose I asked you to solve the equation z squared is equal to 1. Okay, so you need to find, I'm simply asking for the square roots of 1. Okay, then this in polar form is simply going to be 1 exponent 0, exponent 0i. Of course, this is the same as cosine of 0 plus I sine of 0. The theorem tells me that if I want to compute the root of this, then z will simply be 1 raised to a half exponent 0 plus 2 k pi divided by 2 I. So I'm taking 2 because I'm computing the roots. Remember here, I'm looking for z, so that z is the square root of 1. Okay, a number which if I square will give me 1. That's what I'm looking for. And so in this case, I will take k to run from 0 up to 1, where 1 is 2 minus 1. Remember, 1 is the same as 2 minus 1. So we run the values of k from 0 up to n minus 1. When n is 2, so you start with 0, and then n minus 1 is simply 1. So here we will only have 2 values of k to consider. Okay, so the first root will be 1, because 1 raised to a half is actually 1 raised to any number is simply 1. 1 raised to 0, 1 raised to 20, 1 raised to 1,000, you simply get 1. Then when I put k is 0, so this is when k is 0, first case. Put k is 0 here, you simply have exponent 0i, and that gives you 1. So the first root of 1 is simply 1. Now when k is 1, the second root will be 1 exponent of 0 plus, so put k 1, so 2 times pi, that is 2 pi, so 0 plus 2 pi. All of this divided by 2 times I. So what does this give you? When you take 2 pi divided by 2, you get pi. So this is simply exponent of I pi. And this is going to be cosine of pi plus I sine of pi, which is -1. Because cosine of 180 degrees is -1. Sine of 180 degrees is 0. This is very easy to see. If you have a unit circle, so this is 1,
Sure.
1. Yes?
The letters cannot. Could you write those letters in a bigger handwriting?
This ones.
Yeah, k is equals to 1, all that, because it can't be seen well.
Okay, 0 is okay. Is this okay? For k is 0?
No.
K is 0. I hope this will be okay. Then the first root I'm calling Z1 should be 1 raised to a half exponent 0. I, so k is 0. So 0 plus 0 is simply 0. And this gives me 1. Because I need to compute cosine of 0 plus I sine of 0. Sine of 0 is 0, cosine of 0 is 1. So this gives you the root 1. And it is true that 1 squared will give you 1. So that is the first root. The second root, so when k is 1, the second root z sub 2 is 1 raised to a half exponent of 0 plus, I'm just substituting, k is 1, so I put 2 pi divided by 2 I. Now 0 plus 2 pi is 2 pi, divide 2 pi by 2, you get pi. So this is exponent of I, the pi, which by Euler's formula gives you cosine of pi plus I sine of pi, and that gives you -1.
Excuse me, you can see
You can see where?
the end of that statement, the end of that equation, cosine. Yeah, that's better. Thank you.
Okay, now, thank you. So the second root is -1, because sine of 180 is 0 degrees. Cosine of 180 is -1. And I wanted to show you, you can use a calculator, of course, but for unit circle, it's very easy. So if I draw a circle like this, this is the origin, this is 1, 1, -1, -1. This is 0 degrees, this is 90 degrees, this is 180, this is 270, and then from 270 you get to 360 degrees. So if I need cosine of 0, I'll just take the coordinates of this guy. So x coordinate is 1, y coordinate is 0. So that means cosine of 0 is 1, sine of 0 is 0. 180 pi. The coordinates of this point are -1, 0. Because on the x-axis you're at -1, and along the y-axis you're lying on this horizontal axis, so the y coordinate is 0. So that means cosine of 180 is -1, as we have here, and sine of 180 is 0. You can as well go ahead and compute this with your calculator. Now, why I was saying you only need these two values for you to get two distinct roots. Suppose you take k to be 3, or let's take k to be 2. Suppose we take k to be 2. So suppose we consider the case when k is 2. Then that means we're looking for another root, which will be 1/2 exponent of 0 plus. So when k is 2, put 2 here. 2 times 2, that's 4. So it is going to be 0 plus 4 pi divided by 2. This multiplied by I. So this is exponent of, so what is 0 plus 4 pi? That's 4 pi. 4 pi divided by 2 is 2 pi. So this is exponent 2 pi I. Now, compute this by Euler's formula. This is cosine of 2 pi plus I sine of 2 pi. Can someone tell me what you get? What is cosine of 360? Cosine of 360, very fast from our calculator.
One.
Cosine of 360 is 1. How about sine of 360?
0.
0. So in other words, you still get the number 1, but that corresponds to what we got when you took k to be 0. So this is what I meant by restricting the values of k from 0 up to n minus 1, where n is the integer involved with the root. Okay.
I have a question.
Go again to k is equal to 3. You will still keep getting 1 and -1. All three. Go ahead to the question.
There's 1.5 every time before the exponent part. There's 1 raised to a half.
Yes, 1 raised to a half.
Yeah.
Which is
Yes.
simply 1.
Huh?
Which is 1.
Why do we have
1 raised to a half is 1.
why do we keep writing it everywhere?
Why I keep writing it everywhere is because I'm
Mhm.
just substituting in this formula. Z is R 1 over M exponent 0 plus 2k I divided by n times I. So in this case, the absolute value of Z here is 1. So what I'm saying, my R is 1, n is 2. So that means here we'll have Z is, R is 1, so 1 raised to the power 1 divided by 2. That's why I have 1 raised to a half. And then the rest
Oh,
follows
okay.
this.
Yeah, the second question is in 2C, when you said evaluate and locate all the zeros and then you give the equation, this is what you meant. This is what you were supposed to do.
Yeah, this is what I meant. So here you will put you plot here 1, you plot here -1. So we have located the roots on a unit circle. So when you see, what was it about?
It was evaluate and locate all the zeros of z cubed minus 1 is equals to 0 on a
So
unit
those ones,
circle.
so those ones were cube roots. So you were supposed to get some 3 roots and locate them on a circle like this.
Oh, okay.
There's actually an example that is done in the class notes. It's an example that is done on class notes for these groups of unity.
Also, when you do it, do you have to write it in all those formulas, the Euler's formula and the...
No, you don't have to write the Euler's formula. Just know how to
Okay.
apply it. You don't have to write it. Just as long as you understand how to apply it, that's fine. You don't really have to write it. Any more questions? Questions? Any problem with quadratic equations? So I have not checked your assignment yet. I will mark your assignment. I'm not sure today because I have some other commitments, but possibly by Wednesday. I can't promise, but possibly by Wednesday I shall have finished the reading. Let's look at systems of linear equations. Before, I want to recall what we have done. We have solved linear equations in one unknown. And remember, we defined a linear equation as any equation of the form ax plus b is equal to 0, where a and b, the real numbers, and x is an unknown variable. So this was very easy to solve. We simply make x the subject of the formula, give you x is negative b divided by a. Of course, a must not be 0. Where when a is 0, you don't have a linear equation. You only have a constant, an expression that in which the unknown variable is a constant. Then we looked at quadratic equations. Quadratic equations. I hope you are all able to watch the video. So equations of the form ax squared plus bx plus c is equal to 0. So we discussed 3 methods of solving this. You can solve it by factorization, and then you apply the property of real numbers, or in some cases integral domains. It tells you that the product of 2 real numbers is 0 if and only if one of them is 0. Then we also used completing the square method, and then this method was also used to derive the quadratic formula that x is the negative of b plus or minus the square root of the discriminant divided by twice a. And then we looked at some few applications of quadratic equations. Now, systems of linear equations. So we'll be studying equations of this form, but now a set of such equations, not just one equation. We have a set of equations. There could be a set of 2 equations, or a set of 3 equations, or a set of 4 equations. And their known variables do not have to be 1 as we saw before. So here now we can look at system of equations with maybe 2 unknowns, 4 unknowns, 1,000 unknowns, or million unknowns. Such kind of problems are solved daily in real life application. For example, if you go to the airport, if you're trying to plan the flights, which runways are going to use which planes at what time to take off, and they have so many applications. I remember that some of you in high school must have studied what we call simultaneous equations. Not all of you, I assume. Simultaneous equations. So we have, for example, a1x plus b1y plus c1 is 0, and a2x plus b2y plus c2 is 0. So a, b, c are real numbers, x and y are unknown. These are simultaneous equations. It's an example of a system of linear equations. Let me give you a few definitions before we get down to business. So definitions. The first definition of the day is system of equations. So we define this as a set of equations in the same unknown variable. Unknown variables. System of equations is simply a set. So when you talk of a set, you're simply talking of a collection, or a group of equations that have the same unknown variables. Let me give an example. So for example, let's say you have 2x plus 3y is 6, x plus y is 7. This is an example of a system of equations. They are linear because x and y are all of degree 1, and we only have 2 unknowns. So this is an example of a set of equations. This is an example. Let me give you an example of a system which is something which is not a system of equations. So this is an example just for you to see the difference. So suppose you have something like 2x plus 2y is 6, and 4z plus t is 9. This is not a system of linear equations because the first equation has unknown variables x and y. The second equation has a known variable z and t. Z and t are different from x and y. So this is not a system of equations. So for the set of equations to qualify to be referred to as a system, you must have the same unknown variables in all the equations, like in this example here. The second definition of the day is solution of a system. Any question on the definition of a system of equations and the examples? Solution of a system. So this is simply an assignment. An assignment of values, the unknowns, such that all, not this one, all the equations in the system are satisfied. You're looking for variables which you assign to their known variables such that all these equations are true or are satisfied. Okay. Let me give you an example of a solution. So in most cases, we'll be talking about solution as simply a set of these variables which make the equations satisfied in the system. So suppose you have maybe x plus y is equal to 1, x minus y is equal to 0, and someone tells you that x is equal to x is equal to 1 and y is equal to 0. So this is the first equation, this is the second equation. To check that a given set is a solution to a system, just substitute the values in the system and check if all the equations are satisfied. For example, the first equation, so 1 plus 0 is 1, checked, that's obeyed, or the equation is satisfied. The second one, 1 minus 0 is equal to 1, that is also satisfied. So it is true that 1 and 0 are solutions to this system. 1 and 0 are solutions to this system where x and y are unknown. So perhaps for solution of a system, you're simply looking for a set of values which, if you assign their knowns, all the equations in the system will be satisfied. The last definition of the day solving a system of equations. This simply means finding a solution to a system of equations. So we've said a system is simply this set of equations in the same unknown variables. Now the solution will be the set of the values for which all the equations in the system are satisfied. So this process of finding the set of values or assigning values to this unknown such that all these equations are satisfied is what we refer to as solving a system of equations. Any question on these three definitions? So the process I went through in finding x is 1 and y is 0 is what we refer to as solving this system of equations. So the set of x plus y is 1 and x minus y is 1 is a system of equations. There are two equations in two unknowns, x and y. The set of x is 1 and y is 0 is a solution to this system, because when you put x and y into this system, 1 and 0, all the equations are satisfied. That's the solution. the process of finding this 1 and 0 such that all the equations in the system are satisfied is what we call solving a system of equations. Now that we know what's a system of equations, a solution, and how and what it means to solve an equation. So the big question that we need to answer today is how to solve a system of equations. This is the question we'll be trying to answer throughout the week. Now, there are very many methods. There are finitely many methods that the mathematicians have come up with to resolve or to find solutions to systems of equations. So first and foremost, we will start with systems of equations. We'll start with systems of equations in two unknowns. There are three methods I would like us to discuss. The first one is called substitution. The second is called elimination. Then there will be graphical method. There are other methods like using matrices or Gaussian elimination, but in one way or the other, they depend on these two methods. So once you have mastered elimination and substitution methods, then you can solve any system of equations in any variables, even in 10 variables or 30 variables or 50 variables with just elimination and substitution. All the other methods are based on this, be it Gaussian elimination, be it back substitution, they're all based on these first two methods. Then the third method, so graphical method, there are so many softwares for drawing graphs of these equations, and then you simply look at the point where the graphs intersect. So remember, the graph is simply a set of the dependent and the independent variables taken coordinate wise. So when you draw the graph, be it if it's a circle and there's another line, then the solution to the system will be the points where the line and the circle intersect. But we will see that later. So first, substitution. The first method is substitution. Substitution. In general, suppose you want to solve a system of the form a2x plus b2y 0. So x and y are unknowns. In this system, x and y are unknowns. And you want to use the method of substitution. Literal substitution simply means using something in place of the other. So the method of substitution simply involves writing one of the unknown variables in terms of the other unknown variable, so that you reduce a system of equations in two unknowns to just solving a system of equations in one unknown, a linear equation, which is pretty simple, something we did before. So suppose I want to write x in terms of y. Writing x in terms of y. And I can choose any equation of my choice, any equation that I prefer. Let's say I choose the first equation and I want to use this to write x in terms of y and to make x the subject of this formula. So the first step, we will subtract b1y and c1y from both sides of this equation and have that a1x is minus b1y minus c1. Then divide by a1. Of course, a1 is not 0, so that you have x is minus b1 divided by a1y minus c1 divided by a1. Now I have x in terms of y. I can write x in terms of y. So what I will do, I will take this expression of x in terms of y and put it in the second equation. This is what we call substitute. So in place of x in the second equation, write this expression. That is what we call substitution. Let's see how this method works out in an example. So for example, you want to solve 2x plus y is 6 and x minus y is 7. Solve this by substitution. Solve by substitution. We have said for substitution, use any of the equations and write one unknown in terms of the other, and then substitute this expression into the other equation. So let's say I want to write x in terms of y. So this is equation 1. This is equation 2. I want to use equation 2 to write x in terms of y. So from equation 2, x minus y is 7. If I add y to both sides, I will have that x is equal to 7 plus y. That is from equation 2. I've added y on both sides. Or as most of you say, take minus y to the other side. Sign becomes positive. Then substitute this in the first equation. So where there's x in the first equation, replace with 7 plus y. So we will have from equation 1, we can form a third equation, 2 into x. So where there's x, we put 7 plus y. So plus y, that must give us 6. Therefore, 14, so 2 times 7 is 14, plus 2 times y, plus y is equal to 6. Combine like terms, so 2y plus 2y is 3y. 3y is equal to, now subtract 14.
Excuse me, sir. I can't see right below 2 into bracket 7 plus y close bracket.
How about now?
Yeah, that's okay. Thank you.
Good. So subtract 14, so this will give you negative 8. Therefore, y is negative 8 thirds. So remember, by substitution, I have a linear equation in one unknown. So this equation is linear in the variable y, and it's very easy to solve. Just proceed as we did before, and you get negative 8 divided by 3. Now, once you have one of the unknowns, substitute it in any of the two equations, okay, to find the value of the second unknown. So we have y is negative 8 thirds. Therefore, x from the second equation is 7 plus y. So that should be 7 minus 8 thirds. The LCM is 3. So 1 into 3, that's 21. Minus 8. What is 21 minus 8? 21 minus 8.
Sir, will it be minus 8 over 3 because y is equals to negative 8 over 3 and the equation was x minus y. So it will be minus 8 over 3. That should give us. Oh, I see where you're going. Sorry.
If you put, so this is x is 7 plus y. These two equations are the same. So this is the one I've done, 7 plus y. So 7 minus this. What's 21 minus 8? Is it 13?
13. Yeah.
10. So x is 13 hertz. Now you can always check if you have the right solution. You can check if x and y are solutions to this system by substituting in both of them. So let us try in the first equation. If it is not satisfied, then we have not found the right solution. So
Excuse me, sir.
go ahead.
I'm a bit lost.
Where?
After we got the negative 8 over 3, and then now I guess we started substituting it into the equation. I can't see what you've written below there, so I don't know how we got x is equal to 7 over 7 minus 8 over 3.
No, not 7 over 7. It is 7. This is x is 7 minus 8 over 3. Yeah? From here, x is 7 plus y. So x is 7, but y is negative 8 thirds. So I've just put here y is negative 8 thirds. Okay? Then 7 is the same as 7 divided by 1. True or true?
True.
So the LCM of 1 and 3 is 3. Then you ask yourself, how many times does 1 divide 3? It's 3 times. So 3 times 7 gives you 21. 3 divides 3 once, so 1 times 8 is 8. So 21 minus 8, I suppose it should be 13. So this is going to be 13 thirds. So it is 13 thirds. Are you now with us?
Yes, thank you.
Cool. So we want to check if this is a solution. We want to check. So that kind of questions you can always mark yourself before submitting your solution. So we want to check if this system will be satisfied by choosing x as 13 thirds and y as negative 8 thirds. So I want to use the first equation. So 2 times 13 thirds plus 8 thirds. Let's see what that gives us. So 2 times 13 is 26. So you have 26 minus 8 divided by 3. What is 26 minus 8? That's 18. 18 divided by 3 is 6. So the first equation is satisfied. Because if you substitute on the left-hand side, we get what we have on the right-hand side. Let us check for the second one. 13 thirds minus 8 thirds. So minus becomes plus. So we have 21 divided by 3, that gives you 7. Checked. So indeed, x is 13 thirds and y is negative 8 thirds. It's a solution to this system. And we found it by a method called substitution. Questions? Questions? Yes.
Back to where we have written x is equal to 7 minus 8 over 3. I also thought that it was going to be 7 minus 8 over 3. Or did we just substitute the minus because there was a plus?
So what happened is this. The second equation is x minus y is equal to 7. Are you able to see what I'm writing here?
Yes, I can.
Good. Then y on both sides. So this x is 7 plus y. That okay?
Yes.
But what is y? Y is negative 8 thirds.
Yes.
So we will have x is 7 plus negative 8 thirds.
Okay.
This is how you get 7 minus 8 thirds.
Okay. Thank you.
Any more questions or comments? Seems there is none. So the method of substitution is very easy. Simply write one of the unknowns in terms of the other using any of the equations, and then substitute it in the equation which you did not choose, which you did not use to write one unknown in terms of the other. The second method is called elimination. Elimination. So again, suppose you have the system a1x plus a2y plus c1 is 0, a1x plus b2y plus c2 is equal to 0. You want to solve this by elimination. To eliminate simply means to get rid of, in layman's language. To eliminate something or someone means to get rid of them, to remove them from somewhere. Okay? So what this method entails is using one of the equations and then through the operations of addition, multiplying one equation by a term and adding to the other, you eliminate one variable in the unknown so that you have a linear equation. The goal of elimination and substitution, both of them, the goal is from the system of two unknowns. You have a system of one unknown which you solve, and then you use any of the two equations to find the second unknown. So they have the same goal. The idea is to reduce a simultaneous equation to just one linear equation in one unknown. Now, substitution, you use one equation to write one unknown in terms of the other and substitute it in the second equation. Elimination, you eliminate, you use one of the equations to eliminate the second variable from the system so that instead of a system of two unknowns, you have one unknown, okay? And you eliminate by addition and subtraction of multiples one equation the other, we obtain a linear equation in one unknown, and this is very easy to solve. Okay. Now, in this general system, suppose I want to eliminate x. I want to eliminate x from any of the equations. So let me call this equation 1. Let me call this 2. Suppose I want to eliminate x. The easiest way to do that is to make sure that one of the coefficients is the same. Coefficient of x and y is the same in both equations so that I can add or subtract. And in the resulting equation, the new coefficient will be 0 so that I only have an equation in y. Now, so for example, I need something like a1s should give me b1. So this tells me s has to be b1 by a1. So multiply the first system by b1 divided by a1. So this will be, you have a1x plus a2y plus c1 is 0. Multiply this by b1 divided by a1. And the meaning will not change because we said that when you multiply the left side, the right side by the non-zero real number, the meaning of the system does not change. So adding, dividing, subtracting, multiplying, as long as you're not dividing by 0, the meaning does not change. So this gives me a third equation, which is, so b1 times, so let me just write it, a1x times b1 divided by a1 plus a2y times b1 divided by a1 plus c1 times b1 divided by a1 is 0. So simplify, a1 cancels a1, so we have b1x plus a2.
You mind writing in larger?
Y.
Excuse me?
Yes.
You mind writing a bigger handwriting, please?
From where?
There, where you're pointing.
Yeah. Okay. So what I'm doing is simply opening the brackets, multiplying this system by b1 divided by a1. So I'm looking for a third equation. a1 times x times b1 divided by a1 plus a2y times b1 divided by a1 plus c1 times b1 divided by a1 0. If you simplify this, a1 and a1 cancel each other. So you have b1x plus a2 b1 divided by a1 y plus c1 b1 divided by a1 is equal to 0. So this is your third equation. And you have the second equation as, let me write them close to each other, b1x plus b2y plus c2 is equal to 0. This is your second equation. It will be very easy to eliminate x because I have the same coefficient of x in both the equations. I can just subtract them, subtract one from the other. Then in the resulting equation, I will not have any x variable. So by elimination, I've been able to reduce this system to just a system, one unknown, okay? So subtract these two equations, subtract. b1 minus b1 is 0. So you have 0 times x plus, so this is going to be a2 b1 divided by a1 minus b2 all by y plus c1 b1 divided by a1 minus C2, all of this is equal to 0. So realize that there is no x in the equation. Now you simply have a linear equation in y, which you can solve for y very easily. After solving this linear equation in y, substitute the value of y which you obtain in any of these two equations. And then you will find the value of x. So let me repeat again. Both elimination and substitution have one goal. The idea is to reduce a system of two equations in two unknowns to just one equation with one unknown. Then after solving this one equation for the one unknown, substitute the value of this one unknown into any of the two equations to find the value of the second unknown. Let us see how this works out in an example. So for example,
Don't delete. Oh,
so for example,
Sir, we didn't even finish writing the other part.
don't
yeah,
worry,
you deleted.
don't worry, it's recorded. You can always check. Huh? Hello? It's recorded, you can always check. I want us to use the first system. 2x plus 3y is equal to 6. X minus y is equal to 7. You want to solve this system by elimination. Solve by elimination. Okay? Solve this system by elimination. It is up to you to choose which variable you want to eliminate. There is no rule on which variables to be eliminated. You are the one to choose which one you want to eliminate. So suppose I choose to eliminate y. Then I need to make the coefficients be the same or to be additive inverses of each other. So this is equation 1, this is equation 2. I want to eliminate y. So the only way to eliminate y is to make this be -3. It's -1, so I can make it -3 so that -3 plus 3 is 0, and there will be no y. So multiply the second equation by 3. So the third equation is simply 3 times the second equation. So multiply this guy by 3. 3 times x is 3x. 3 times -1 is -3y. 3 times 7 is 21. We have the first equation as 2x plus 3y is 6. That's your first equation. To eliminate y is easy now, because -3 and 3 are additive inverses of each other. That means when I add them, I get 0. Now add these two equations. So the fourth equation is going to be the sum. 3x plus 2x is 5x minus 3y plus 3y. That is going to be 0y. Should give you 21 plus 6. That gives you 27. Is it 27? Oh, this was
Yes.
This was 2x. Sorry, this was 2x. I mean,
No, you are
2x.
eliminating. You're using the
by 3.
By 3.
Okay, it's okay. It's okay. Huh? It's 3x. Huh? Wait a minute. That should be 2x plus. Yeah, it's okay.
Okay.
So 3 plus 2 is 5. Minus 3 plus 3 is 0. 21 plus 6 is 27. Okay, so this means that x is going to be 27 divided by 5. Did you make a mistake somewhere? Hello?
There's no mistake, sir.
You made a mistake somewhere.
No.
Is this the same system that we solved before when we were doing substitution? Because we seem to get a different value for x.
No,
It
Other one
was
was x
different.
plus y.
The other one was x plus y.
It's 2x plus y.
Is x minus y.
The other one was x plus y.
Yes.
Ah, okay.
No.
Up to
X.
Sorry. It was, so the first equation was 2x plus y is equal to 6, and then x minus y is equal to 7.
Okay, let us just carry on with this and see if we get, so we first have x is 27 divided by 5. Huh? That is the first unknown which we have obtained. Now we can substitute this in any of these two equations. Substitute x in any of the equations. Substitute x is 27 over 5. In which equation? Equation 2 will be fine. Equation 2. So equation 2 is x minus y is 7. I have x as 27 over 5. So take 27 over 5 minus y to give you 7. We now solve for y. So this means that y is 7 minus 20. This means y is 25, I mean 27 over 5 minus 7. From this, now the LCM of 5 and 1 is simply 5. So 5 into 5, 1, 27, minus 1. So 1 goes into 5 times, so 5 times 7 is 35. And what's 27 minus 35?
8.
Negative 8.
Minus 8.
8 divided by 5. So let us see. X is 27 over 5. Y is minus 8 over 5. Is this a solution to this system? We want to check if this is a solution to this system. So check the first system. If 2x plus 3y is 6. Now checking 2x plus 3y. So 2 times 27, that is simply 54. Okay. 3 times 8, 24. So minus 24 divided by 5. 30 divided by 5 is 6. So the first one is checked. Okay. Let us check the second. Allow me to wrap this part. X is 27 over 5 minus y. Y is minus 8, so minus 8 over 5. So this is going to be plus. So 27 plus 8 is 35. Divided by 5, that gives you 7. Checked. So we have solved that system by elimination. And again, you have realized that in elimination, substitution finds, there's some element of substitution even in elimination, because after solving one system, solving for one unknown, you use this unknown to find the second unknown. You do that by substitution. So in a way, elimination depends on substitution, but they all have the same goal. The goal is you're given a system of 2 equations and 2 unknowns, and the first way of getting around is to reduce this system to an equivalent system with just one unknown. After solving for this one unknown, you can use this one unknown to solve for the second unknown. And these 2 methods can be applied in solving bigger systems where you have not just 2 unknowns, but 30 unknowns, 10 unknowns, 4 unknowns. But now it will be very hectic to do this by hand. So there are softwares, there are programs. You find programs in Python or Sage or Mathematica, MATLAB, Scilab, Singular that can do this. This is what people use in the, you don't expect someone to be writing a system that has 100 unknowns. You leave that to the computer. That theory is already developed. Question on elimination and substitution. Any question?
Question.
Go ahead.
Excuse me, sir. Okay, when you began the elimination method, you wrote 3x, and I was wondering where the 3x came from.
where the 3x came from.
Yes, when you were starting right at the beginning, the third equation was 3x. Did you add 2x to x, or what happened?
No. Okay, so first my goal was to eliminate y. Okay.
Okay.
To eliminate y, I need to make sure that the coefficient of y in the first equation and coefficient of y in the second equation are either the same or are additive inverses of each other. So one is 5, another one is -5, or one is 5, another one is 5, or one is 3, another one is -3. So in the first one, I already have a 3. I can make this -3, okay? By multiplying the whole system, the whole equation by 3. So my third equation here became 3 times the second equation. So multiply this equation by 3. 3 times x gives you 3x. 3 times -y gives you -3y. 3 times 7 gives you 21. Now with this third equation and the equation 2x plus 3y is 6, which is the first equation. I have coefficient of y as 3, coefficient of y as -3. 3 and -3 are additive inverses. I can eliminate that by simply adding up these two.
I understood.
Thank you. More questions?
Excuse me.
Yes.
Would you please do another example?
Yes, we will do another example. But before the example, I think someone will ask me this question, but now let me ask you this question. Do you think all systems have solutions?
No.
Anyone with an idea? Do you think all systems have solutions?
No.
No.
Why? Why not?
Sometimes the solution may not be a real solution.
Sometimes the solution may not be a real solution. Well, if it's not real, it could be complex, and that is still useful. It's true you may not always find real solutions, but even complex solutions are useful. So, not all equations will have solutions. Let me give you another example. You wanted an example of using elimination or substitution?
Elimination.
Using elimination, cool. Then we can discuss when and what. So when do we have solutions? When can we find these solutions? Okay, so this time around, I'll give you the problem and then I sit back and you're the ones to give me ideas on what to do. So let's say you have, I don't know. 4x plus 3y is equal to 7. X plus y is equal to 2. This is the first equation. This is the second equation. Solved by elimination. Solved by elimination. Yes, you guys must give me ideas. Which variable do you want us to eliminate? And how do we proceed?
2.
We eliminate 2. The unknowns are x and y.
Let's eliminate x.
We eliminate x. So how do we eliminate x?
The first one, we leave it like that. The second equation, multiply by -4.
Multiply by -4. Okay. So we look for a third equation by multiplying this second equation by -4. So that gives you -4x minus 4y is -8. This is your third equation. And you say that the first equation will leave it the way it is, 4x plus 3y is equal to 7.
Where are you getting the -4 from? -4x?
The person who said -4, would you answer that, please?
Yeah, I wanted to eliminate x. So I found a number that if I multiply the second equation, I can eliminate x in the first equation. So -4 would give me -4x for the second equation, and I'll still have 4x in the first equation. So I have the possibility to cancel -4x and +4x. You can choose any other number depending on what you want to eliminate.
Yeah, that was a very excellent answer, but choose your words wisely. You don't say you have a possibility to cancel. There's nothing we're canceling. So when you are adding, you don't say you cancel, okay?
Okay, sorry.
Yes, yeah, but great answer. So to eliminate, there are two ways. You can eliminate by addition or by subtraction. If you want to eliminate by subtraction, make the coefficients of the unknown which you want to eliminate to be similar. So if I wanted to eliminate x by subtraction, I will make coefficient of x in this second equation 4, or I make the coefficient of x in the first equation 1. That is if I want to eliminate by subtraction. So that I will subtract x minus x or 4x minus 4x to give me 0. If I want to eliminate by addition, then I make coefficient of x in this second equation an additive inverse of the coefficient of x in the first equation. So in the first equation, we have 4. Additive inverse of 4 is -4. So I make coefficient of x here -4. The only way to do this without changing the meaning of the equation is to multiply the whole equation by -4. I could also make coefficient of x in the first equation -x, or I mean -1, sorry. So that -1 plus 1 is 0. And the way to do that for the first equation, I could multiply it by -1/4, so that I will have -x and x. -x plus x gives you 0.
So, sir, just to confirm.
Yes.
If it was y that we were eliminating, then would we multiply the second equation by -3?
Yes. Okay. You multiply by -3 if you want to eliminate by addition. Okay. You want to eliminate by subtraction, you will multiply it by 3, so that you have 3y, and then just subtract.
Okay.
Yes. Now, there are so many options for you. Okay. So now, how do you proceed from here?
We add the two equations.
Add the two equations. So the fourth equation, add these two equations. -4 plus 4 is 0. -4 plus 3 is -1. So minus y is -1. So -8 plus 7 is -1. Therefore, y is equal to 1. So adding these two equations gives you a linear equation. The solution is y is equal to 1. Use this y is equal to 1 in any of these two equations to find x. So if I choose the second equation, where x plus y is 2. So I will do x plus y is 1, should give me 2. Therefore, x is 1. So I have x is 1, y is 1. And you can check, if you put x1, y1, 4 times 1 plus 3 times 1, that is 4 plus 3 gives you 7. X plus y, 1 plus 1 is 2. So indeed, x is 1 and y is 1, solve this system. And in some cases, you can write this coordinate-wise as x comma y is the same as 1 comma 1. So this means x is 1 and y is 1.
I have a question.
Yes.
In the part where we added equation 3 to equation 2, the decision that we made to add, is it dependent on the method of elimination that we decided to do? Like if we decided to eliminate it by subtraction or addition, then that would tell us whether or not we need to add or subtract.
Yes, if you decide to eliminate by addition, look for coefficients which are additive inverses of each other.
Mhm.
If you decide to eliminate by subtraction, look for coefficients which are the same. So
Mhm.
the decision to add or subtract depends on which method you wanted to use. Were you intending to eliminate by adding or intending to eliminate by subtracting? So it's a decision you make from the concept. I want to eliminate by addition. So let me make one coefficient an additive inverse of the other. Or I want to eliminate by subtraction. Let me make coefficient of one variable the same in all my equations.
Okay. And then also then the -4 that we used to create, sorry, the third equation, was that elimination by addition or subtraction?
This is we wanted to do addition.
Okay.
We make coefficient of the second equation -4 because we already have 4 here. So that I'm just added these two equations. So -4 plus 4, 0, -4 plus 3 is -1, -8 plus 7 is -1. So now the fourth equation is simply unknown in y. So you have eliminated x from this system by adding. Yes. Now you can solve for this unknown and then use it, any of the two equations to find the second unknown variable.
All right. Okay. Thank you.
More questions? Now, I've already hinted that not all systems will have solutions. There are some systems which do not have solutions. So a remark. Systems of equations in two variables systems of equations in two variables for system. Let me put for any system of equation in two variables. One, but not all of the following statements is true. So for any system, one, but not all of the following statements is true. The first statement is that the system has a unique solution. Two, the system has infinitely many solutions. And lastly, the system has no solution at all, no solution. So such systems are called inconsistent. Inconsistent. The ones which have infinitely many solutions are called dependent.
Excuse me, do you mind moving the board a bit to the left?
Moving the board to the left. Let's see.
Just slightly. Yes, thank you. Yes.
So each of these statements, one of these statements is true, but not all of them. For any system of equations, you could have a unique solution. All the examples that we gave in this class are systems that have unique solution. You could have infinitely many solutions, or you could have no solution at all. So I know I've not given you examples of systems with infinitely many solutions and systems with no solutions at all. So for the last part of this class, I will give you an example of a system with infinitely many solutions. In some cases, we refer to them as parametric solutions, and also an example of a system with no solution. Let me start with a system. Let me start by a system with parametric solutions. Parametric solutions. Solve the system. Solve the system. So you have x, x plus y. I don't know, it's equal to 1. 2x plus 2y is equal to 2. It's a very nice, it's a very simple system. X plus y is equal to 1, 2x plus 2y is equal to 2. Now, use any method.
Excuse me, sir. Do you mind moving the board now a bit to the other side, because I can't see the figures after the equal sign.
Does that work?
Like that. Yeah.
Okay, so I want to solve x plus y is 1, 2x plus 2y is 2. Use any method, substitution or elimination. Let's say we want to use elimination. Okay? Suppose you want to use elimination. So by elimination, I would make coefficients. So I would multiply the first equation. So this is your first equation, second equation. I multiply this by -2. So you get minus 2x minus 2y is equal to -2. This is your third equation. I've multiplied the first equation by -2 because I want to eliminate by addition. So I need to make coefficient of x here -2 because I already have coefficient of this guy as +2. Add these two, -2 plus 2, that's 0. -2 plus 2, that's 0, is equal to 0. What does that tell you? 0 is equal to 0. 0 is equal to 0. Is that a true or false statement? Hello?
It's true.
It's true. So once you find statements like this, it means your system has no unique solution. Your system has what we call parametric solutions, or infinitely many solutions. And however much you try to eliminate one variable, you will not succeed. You will never succeed in eliminating one variable from the system. So what you do is decide on any of the two systems and write one unknown in terms of the other. So if I decide to use the first equation where x plus y is equal to 1, this means x is equal to 1 minus y. Now the solutions for this system will depend on some parameter. Introduce a parameter. Introduce a parameter. Parameter could be t, s, or anything. So that x is equal to 1 minus t and y is equal to t. So the solution for this system, given coordinate wise, x comma y will be 1 minus t comma t, where t is a real number. So in this case, t is called a parameter, and this is called a parametric solution. This is simply a short way of writing x is 1 minus t and y is t. So for each and every value of t you choose, you get a particular solution. For example, let me show you some particular solutions for that system. If we choose t is 0, if you choose t is 0, then x will be 1 and y will be 0. Now check if x 1 and y 0 will solve this system. If put x is 1, y is 0. 1 plus 0 is 1. First system is satisfied. Second system, 2 times 1, that's 2. 2 times 0, 0. So 2 plus 0 is 2, satisfied. So t0 satisfies this. If I put t is 10, then x will be 1 minus 10, y will be 10. So we have x, this is going to be -9. So we have -9 and 10. Check if -9 and 10 will solve this system. If you put 10 minus 9, that is 1. So the first system is satisfied. 2x plus 2y. So 2 times 10 plus 2 times -9. This is 20 minus 18 gives you 2. Second system is also satisfied. So this is also another solution. For any real number you choose to be t, you either use a million, a billion, a trillion, 30, 700, a half, -40, you always find a solution. So this is what we call a parametric solution. This system has infinitely many solutions because you have infinitely many real numbers, and every real number you put here, you find a solution. Questions? Before I give you an example with of a system with no solution at all. Any questions? No questions. System with no solutions. In short, let me just say inconsistent. Inconsistent system. An inconsistent system. So a system for which you will never find a solution. It's very easy to get an example. X plus y is 1. 2x plus 2y is 4. When I make it simple, let me make this simple. This is 3. Try to solve this system. Try to solve this system by any method of your choice, with elimination or substitution. Are we there? Hello?
Yes, sir.
Yes, solve this system. So which method do you want us to use? Which method do you prefer?
Substitution.
Substitution. So you see the first equation, I can write x as 1 minus y. I've subtracted y from both sides of the first equation, okay? Substitute this in the second equation. So 2 into x, so 2 into 1 minus y plus 2y must be equal to 3, okay? Is everybody fine with this step?
Yes.
Yes.
Open the
Yeah.
brackets. 2 minus 2y,
Minus 2y plus 2y.
y is equal to 3. What do we have next?
Two is equals to
And
3.
then the like terms.
What?
2 is equals to 3.
Is equals to 3.
2 is equal to 3. What does that tell you? What can this tell you?
Inconsistent because 2
Why?
cannot be 3.
Sorry?
It's inconsistent because 2 cannot be 3.
Yes, 2 can never be equal to 3 because when you say 2 is equal to 3, then it means there is only one real number. It means all real numbers are the same. Because saying that 2 is 3 is the same as saying that 1 is equal to 0. And therefore, all real numbers are the same. Okay? Or saying that -1 is equal to 0. So this is an inconsistency. So when you meet such absurd statements, it means the system is inconsistent. And by the way, you'll always find some, if I'm trying to test if you know that a system, not all systems have solutions, I'll bring in inconsistent systems like this. And you'll have to explain to me why you think the system is inconsistent. So this is inconsistent because the statement 2 is 3 does not make sense. It's not a true statement. We know that 2 and 3 are distinct real numbers. So in the real number line, from 0, there is 2, there is 3 somewhere there. So these points are separated by 1, and they're not, 2 can never be equal to 3. So the system is inconsistent. Any question on what's a system? How do you solve a system? What's a solution of a system? Elimination, substitution, whether a system is consistent, inconsistent, or with unique solution, or with infinitely many solutions. Any questions? Okay. The third method is called, before the third method, because we have done quadratic equations, I want to give you a system in which one of the equations is quadratic and one is linear. Solve the system. X squared plus y squared is equal to 4. Any ideas? So we have the first equation is quadratic in x and y. The second equation is linear in x and y. First of all, how many solutions do we expect for this system? If at all there are solutions. I'm not sure if it has a solution. I don't know whether it's inconsistent, but so suppose it is consistent. How many solutions do you expect? How many solutions?
4.
4. Okay, by a solution, I mean if you find a value of x that corresponds to the value of y, we treat that as one solution. So I guess you're referring to two sets of solutions. Huh? By the fundamental theorem of algebra, an equation of degree 2 will have at most 2 solutions. You cannot have more than 2 solutions. So if it's of degree n, it has at most n solutions. So very first, we want to use substitution. The second equation, this is first equation, second equation. From the second equation, I can write x in terms of y, subtract 2y from both sides. So x is equal to 1 minus 2y. This is from the second equation. Now substitute this in the first equation. So where there is x, replace with 1 minus 2y. So we have 1 minus 2y squared plus y squared is equal to 4. I've substituted for x with this. And how do you do this? So you just expand 1 minus 2y times 1 minus 2y plus y squared is equal to 4. You know that a squared is simply a times a. So this is what I've done. I've taken 1 minus 2y times 1 minus 2y. Open the brackets. So 1 multiplied by 1 minus 2y minus 2y multiplied by 1 minus 2y plus y squared must give you 4. So open the bracket by 1. So this is 1 minus 2y minus 2y times 1 is minus 2y minus 2y times minus 2y. This is plus 4y squared. So plus y squared, this gives you 4. So this here we have 1 minus 4y plus 4y plus y squared, giving you 4. So this gives you 5y squared minus 4y minus 3 is equal to 0. Have you made such equations before? 5y squared minus 4y minus 3. What kind of equation is this?
Quadratic.
Quadratic equation. And you can solve this using the formula. So the formula tells you that y should be 4 plus or minus square root 4 squared minus 4 times 5 times minus 3 divided by 10. So this should be 4 plus or minus square root of, so 4 squared is 16. 4 times 5 is 20. 20 times 3 is 60. 60 plus 16 is 76. Divided by 10. So that the first value of y is 4 minus square root of 76 divided by 10. Second value of y is 4 plus square root of 76 divided by 10. So a quadratic equation will have two roots, and these are the two roots, 4 minus 76 over 10 and 4 plus 76 divided by 10. Now, for each value of y, you can find the value of x from this. Remember this, x is 1 minus 2y. So x1 will be 1 minus 2, y1, x2 will be 1 minus 2, y2. And this system will have two solutions. You will have x1, y1, and x2, y2 as your solutions. Questions? So this is why you needed to have mastered the quadratic equation. Should you identify this quadratic equation, you can use the method, you can use this formula to find the solution. Then once you have these two values of y, just put them back in any of the two equations to solve for corresponding values of x, and you will get two solutions: x1, y1, and x2, y2.
What are the values of y that you have written down there?
The values.
Yeah.
Yeah, that's for you to do. So you are supposed to compute this. The y here is 4 minus 76 plus 10. So x1 will be 1 minus 2 into 4 minus square root of 76 divided by 10. X2 will be 1 minus 2 into 4 plus square root of 76 divided by 10. You should go ahead and do these computations with your calculator. But in case of the exam, I'll be fine with this. Huh? I'll be fine with this. Because we are aware that 76 is an irrational number. So just leave it the way it is. Questions? So in the next class, we will look at graphical methods and also see how you can, modify elimination and substitution to solve higher order systems. So systems with 3 unknowns, 4 unknowns, 5 unknowns, 700 unknowns, 1,000,000 unknowns. Okay. We look at things like Gaussian elimination, back substitution, and I will also try to show you how to plot some of these graphs and how to be able to extract solutions from the graph. If there's no more questions, that's all for today. See you on Wednesday.